Okay, so we have one more problem for your homework set for the law of sines, and I'm just looking around here, and they have a bunch of neat problems here. However, I think I'm going to do one that I've done before and given to people on tests, just because you never know. You might get a devil just like me. I'm going to try and draw this as best I can. Your book, trust me, it has one, and you'll just have to pretend that these are drawn even closely like they're supposed to be. Like that's not supposed to happen. No. Okay. Oh. Youch. Hey, that's not too bad. Okay, so you got three balls. Don't even think that way. I heard that. And this is C, and this is 8.23. 3. This is called A, and this is 13. And they're not giving us any units. And this is B, and this is 11.27. And what they want, assuming that the circles in the figure are all mutually tangent, find the lengths of the sides and the measures of the angles of the triangle ABC. Okay, so here's what they want. So here's the triangle ABC. We're connecting this up. I put this on a test, and students just seem to habitually not know how to think about something like this. And what happens is they go, I have no idea what to do. And they'll either sit and look for 5 minutes, burn 5 or 10 minutes up, or just forget it. Never just sit and look for 5 minutes, maybe 2 minutes. Do something, just wiggle around stuff. First off, the lengths of the sides is a piece of cake. Why? Because all you have to do is rotate these two things in place. This radius here goes right here. Actually, I'll put it different color. This goes right here, and it didn't change anything. This is 8.23. This, we can swing over here, goes right here, and this is 13. So right away, from here to here, so I'll draw this other triangle. This is supposed to represent this triangle right here, and I'll even mark it C, A, and B. So we have 8.23 plus 13 on a good day. This is 21.23. Once again, they didn't give us any units, feet, or whatever. Similar, I'm just going to take this. The radius doesn't change, so this must be 8.23. And this must be 11.27. And am I going to be brave and just do this in my head? Well, 8 and 11 is 19, and 23 and 27 is 50, so this is 19.5. And so this one's 19.5. Okay, and lastly, we have this. We're going to move this over here. It's like this is on a freewheeler, and this is going to be 11.27, and this will be 13. So 13 and 11.27 is 24.27. And now we really know how to do this. We've done something very similar to this already. Across from angle A, this is small a. Across from angle C, this is small c. And across from angle B, this is small b. Why do I need that? Well, okay, so now we're going to go with our formulas. Remember that a squared equals b squared plus c squared minus 2bc cosine A. I guess I'll do it one at a time. We need to figure out these angles. All I have to do is figure out two of them, and then the third's a cinch. But the first thing, notice the first thing about this problem is you look at it, most people look at it and they go, where the hell do you start? And the way that you start things that you don't know how to do is fiddle around and stuff. And you don't have to edit the swear word. That was meant to be there, to be ironic. Where do you start? Really, this is what drives students crazy. If you don't know where to start, just do something. Do anything that's on your paper with relevant to your test. Okay, so this a squared minus b squared minus c squared divided by minus 2bc is cosine of a. Well, that will be, what a squared is 19.5 squared minus b squared, which is 21.23 squared, minus c squared, which is 24.27 squared, divided by minus 2b, which is 21.23, and c, which is 24.27. I'm going to do the top of this, and then I'm going to do the bottom of it, and then I'm going to do it on the calculator. Here's the deal. The TI-83s and whatever, if you use the right punctuation, you can see that you've done this right, but this isn't that sophisticated. I don't trust the syntax of this all the way through this. Just there's so many operations going on. So we have 19.5 squared minus 21.23 squared minus 24.27 squared. My trusty calculator says that this is minus 659.4958. So this is minus 659.4958. I'm going to wait until later before I truncate this. The bottom is going to be minus 2, oopsie, times 21.23 times 24.27. You see how easy it is to just let a small mistake slip into these things. This is minus 10305.042. Okay, so the minuses cancel out. Let me do some division. This is 659.4958. Turn it upside down. So, according to this, and if I've done this properly, the cosine of A is equal to 0.63997 and some change. That means that the arcos of this 0.63997 and change is equal to whatever A is. And I'm going to do that now. I'm in degrees. This says this is 50.21 degrees. Next, all we have to do is find one more, and then we can find the third angle by subtracting 180 degrees, or the two angles that we got, or 180 degrees minus the two angles that we got. It'd be nice if I could talk today, wouldn't it? So we were interrupted. Our IT guy had to get out of here, and it's a different day, but I want to continue this problem. We solved everything. What did we do? We figured out what these lengths were by cranking around the varying radii and matching them up. Then we figured out what angle A was by similar process of the same way we're going to find angle B. We know that B squared equals A squared plus C squared minus 2AC. That means with a little algebra, cosine of B is equal to this. I have this number up here, 21.23 squared minus 19.5 squared minus 24.27 squared divided by 2 negative divided by 19.5 divided by 24.27. So this is 0.54786 blah blah blah. I'm going to hit Arcos. This says it's 56.78 degrees, and I already approximated it. So this is 56.78 degrees. That means that this is 180 minus this, minus plus 180, minus 50.21. So this is 73.01 degrees. Basically, 180 degrees in a triangle. I just subtracted this and this from 180. We're probably out of time, so I'll see you, well, in a minute for me.